it's recording now.
Okay, cool. Okay, so I'm going to talk a little bit about weights and biases. It's a really cool tool, and I'm going to talk about it in the context of this machine learning challenge that I recently worked on, which was the AI for EO challenge for food security. And so I'll give you a little bit of context about this challenge first of all, and then dive into how the tool was actually useful. So the challenge basically was given a whole bunch of satellite data and then labels per field. So labels of the crop that's growing in each field. Try and make a good crop classification model that can work on a different region. So we were given all these labels for a particular region in South Africa, and then given another region with no labels, and basically asked to make predictions on that region with no labels, and submit those results, and then we'd get a competition score. So that was the project. And so I'm going to go ahead and open up some of the code for this project. So this will get maybe a little bit technical. So if this is not really, if the model training with PyTorch and whatnot is not really your thing, then I won't be offended if you tone out. But basically, I'll first show the file, my training script, essentially, what it looked like before weights and biases, and then what it looked like afterwards. So here's my file for training my crop classification model without weights and biases. I have a bunch of imports at the top, and then just some standard kind of stuff like setting some random seeds, and then adding a whole bunch of arguments for all these different things I might want to modify when I'm training the model. For example, the batch size or the amount of epochs that my model is running for. Yeah, this is just a continuation kind of putting all these arguments into one dictionary so that it's easy for me to access these arguments and use them in code that goes further. Some of these next lines are just about initializing the data loader so that the model can actually use the data. This is all not hugely important, but I'll just go through it just so you kind of have an idea of what this file is doing. So yeah, all these rest of the lines are about initializing the data loader. You can see there's a train loader and a validation loader for the model to train on. Then I have a line actually initializing the model, again, with all these parameters from the configuration dictionary. And then I have some specific parameters for training, for example, which optimizer to use, or if I wanted to use a learning rate schedule, or all these pretty machine learning specific things. And then finally, I have some lines to actually do the training. And essentially that just means looping through a whole bunch of training epochs, and then training the model, getting the training loss, and getting the validation loss. So recording all of those, and then calculating some scores and confusion matrices. So all these sorts of things that you'd usually do in a training kind of script. Yeah, so that's basically it, 200 lines. Pretty standard for the most part. And how I would run this is I would go into my console over here, and I would usually make a screen session. So that's just so I have it kind of running in case that this closes, it's still going to be running inside a screen. So I'll call this, I think I already have one train, so I'll call this one train 2. So now I'm inside a screen. And then I'm going to, for all this sort of model training, especially with a lot of data, you often want to use a GPU. And in this case, I'm actually logged into the slurm cluster that's provided by the Center of Machine Learning. So just kind of quickly to give some context about how that works is basically, we can just look at this picture and that'll give it a good summary. Like this is my computer right over here, and I'm logged in, like I have VS Code open inside of this login node. And then with certain commands, I can access these compute nodes, and these compute nodes are what have GPUs on them. And so I can access just one, which I'm going to do right now, but I can also access multiple at the same time. That allows me to train several machine learning models. So I'm going to go ahead and run a command to access one of those nodes interactively. I'm just going to copy and paste this command into here. So this is just saying, run a machine with GPU using this particular account, give me at least 32 gigabytes of memory, and give me 24 hours with this node. So that's all. That line now gives me, now this console has access to a GPU machine. And so now I can run Python train without weights and biases, and I can go ahead and run this file. And I'm going to run it with all the default arguments. So I'm not going to set anything. I guess I could set the learning rate just as an example of how it would look like. So the default learning rate is 0.001, but I'll set it to 1 as an example. And I can go ahead and run this file, and it's going to start going through this script, loading everything, and the first line that you'll probably see is data sets initialized. Yeah, okay, so here you go. Loaded some data sets initialized. Let me make this a bit bigger so it's easier to see. Okay. Data loaded, model initialized. Now it's printing out this whole configuration dictionary, and now it's starting to train. And you can see there's a train loss over here. That's cool. So my model is beginning to train. But now, okay, let's say I have this model training, and later I want to train another model. How am I going to compare this? And people use different methods. What I sometimes used before was I would add a lot of these configuration things to like Google Sheets, and then record what the training loss or the validation loss was after like a whole bunch of runs, and then take a look at that afterwards. But that kind of is a lot of bookkeeping, and I'm not a librarian. Like I'd rather do machine learning engineering. So that's why I looked into weights and biases basically. So I'm going to go ahead and stop this run. And I'm going to make this a little bit smaller, actually, it's too big. And I'm going to go ahead now and open up the file that has weights and biases. And just to show you what it looks like when you add it in. Let's see, where's compare select? Okay, wait, this is. Okay, cool. So on the left, I have the original file, and on the right, I have the lines with green are the lines that I had to add to make weights and biases work. So first, it's a Python package, so I just have to import it like so, import weights and biases. Then this is really not necessary, but it was useful for me. I have a particular argument to say disable weights and biases, because not every time I want to use it. Sometimes I just want to test out that I have no bugs in my code. In that case, I want to disable weights and biases. Okay, and this is where it starts to get interesting. So weights and biases, really like the big purpose of it is to help you track your model and to track all your different training runs. So here what we do is we initialize one run and we say, initialize it to be in this particular entity. This is like a folder I have, NASA Harvest, initialize it for this project. Add all these configuration things that I had set earlier, add it directly into this run. And then there's some settings that are not super important. So this is an important line, wandb.init. And let's see what other lines are new. Pretty small thing here. I just changed the model path to reflect the run that's happening. Another small thing over here. And here's the other most important line. And this is wandb.log. So this line is inside of the training loop. So it's going to be called every epoch, every time that the machine learning model does a whole run through the entire training set. And what it's going to do is it's going to log losses, a dictionary of losses. It's going to log the epoch. It's going to log some metrics, and it's going to log a confusion matrix. And then we have a small line here to save the model to weights and biases, and then run.finish. So that's pretty much it. Not that many lines added in. I guess it went from 244 to 280. So 40 lines maybe, but you could do even less. So I'm going to now inside over here, inside of my command line, I'm already inside of a GPU machine. So I'm going to just run train.py and it's going to run the file with weights and biases now, and we'll see what the difference is. So it's going through the same steps it did before, initializing the data set, loading the data, beginning training. And now you see I have some new logs from weights and biases, and I have one that says view project and one that says view run. So I'm going to go ahead and view the run. Okay, so nothing here yet, and that's because the model hasn't gone through a whole epoch yet, and there's nothing logged. But I can look at the overview, and the overview is going to tell me just some kind of things that it can be set right away when the model starts, for example, the start time. But what's more interesting to me is that it has all these configuration things that I set right over here. So for example, the learning rate or the loss that I used or the input dimension, it saves them all, which is pretty neat. And I actually started a run before the start of this meeting. So I'll just show you an example of that one. I think it was this Winter Dragon one. So similarly, if I go to the overview of this one, it has all these configuration things. But now I'm going to go to charts in this run that I had started before. And in charts, I can actually see the losses that have been logged. So this model has been running for 40 epochs, and I have a training loss, which is the orange line, or the blue line, sorry, and a validation loss, which is the orange line. I have the accuracy being logged as well. I have the F1 weighted score. I have the confusion matrix. And then I have a whole bunch of other metrics that I log, but I don't necessarily look at, like precision micro, like a very specific metric. So that's cool. That makes it easier for me to see what's going on for one particular model. But the other really big advantage is that I can look at multiple models. So if I go back to runs, here's the one I have running. Here's the one I just showed you, the Winter Dragon one. And here it is on the side panel. I can also look at other ones in comparison. So here's a previous run from a sweep actually. And I can see how its training and validation losses compare. So the gray ones are from this other model and the green ones are from the one I showed you previously. Same with, I can compare the confusion matrices, for example. And if I want to take a look at like more general comparisons across a whole bunch of parameters, I can open up this whole table view and I can click automatically show the most useful columns. And now it's supposed to show me some columns that are more useful, so that are maybe different across these runs. So for these two particular ones, if I compare Winter Dragon and Youthful Sweep, I can see the input dimension is different. This one has input dimension of 21, this one has 14. The learning rate is also different. The number of epochs are also different. So this makes it easy for me to compare. And then I can see the accuracy is also the metric, at least the max accuracy for the entire model training run is different. So this makes it easy to compare two runs. I guess let's see if this one has anything for us. Nope, it looks like it's still running. But what's also neat is that I can actually see what is, I can see the logs that are happening on the machine. So this is what is being printed out on my machine right now. 1.28, 85%. And then here I have the same thing. So it basically has whatever I have running right here. Oh, and it looks actually just that the validation loss just finished. So that means I should have something here soon. Oh, cool. So I have the confusion matrix, for example, and I have just one value for accuracy, which is pretty low right now, 47. So that's that. But now what if I want to run like, a whole bunch of models at the same time? That's what's interesting to a lot of people. And what if I want to use a whole bunch of these nodes at the same time? So this is where weights and biases is also very helpful. I guess I can just leave this one on. But I'll have to give some more context about slurm, like this kind of cluster which I'm using. by default, or like what the command that I just used is in interactive mode. So basically I access that that GPU in the bash terminal, so I can actually see what's going on in there. But you can also access it in a batch mode. So that means you just send the GPU the command that you want to run, and the GPU just runs it, but you don't have any access to it. So if it fails, it fails. You can't go in there and look. You can only look at the logs. So that's kind of a way to run a whole bunch of models at once. And I'll show you how this is done with weights and biases. Actually, no, I'll show you what I did before for sweeps, and then that'll motivate weights and biases better. Before, let's say I was I go back to this, and I go back to my run over here, and I see that I have a learning rate of what did I have here? 0.001. And I would say, okay, I want to check out, maybe the learning rate is going to be better, or the model is going to perform better if the learning rate is 0.01 or 3 zeros and then a 1. So what I would do before is I would go in and I would create a new screen session, and I would go in here and I would do the srun command. Let's see if I have it saved. I'd log into another GPU, and then I'd write python train.py lr 0.01, for example. And then I'd write another one which like this, and then another one like this, with all these different learning rates. But if I want to test a whole bunch of values, then that gets kind of difficult, especially if I want to test how learning rate and batch size, how they kind of correlate together. So for that reason, that's why I started looking into weights and biases sweeps. So weights and biases sweeps are basically a way to test a whole bunch of parameters without having to run your training script, like, I don't know, hundreds of times or dozens of times. Basically weights and biases does that running for you. So what I've opened up here is an example sweep file. And so what this looks like is that at the top, I tell weights and biases which file to run to train the model. I tell it which method to use for the sweep search. In this case, it's grid search. I tell it the goal. So the goal in this case is to minimize the validation loss. And then I tell it the different parameters to use. So when I have just one parameter, that parameter will be used by default. So like in this case, spatial backbone, the value is pixel set encoder. But if I have a list with square brackets, then that means that multiple values will be used inside the sweep. So in this case, I have a parameter called pixel set encoder sample size, and I have two values here, 4 and 16. That means that weights and biases will do one run with this parameter set to 4 and another run with this parameter set to 16. So I'm going to go ahead and copy this and go to weights and biases, and I'm going to create a sweep. So I can navigate to this sweeps button on the side, and I'm going to click create a sweep. And it's got an example one for me, but I'm going to post my own example. And I don't want to do this many tests. Let me just eliminate some of these parameters. We don't need to run through all of them. And I'm going to change the satellite to be Sentinel-2 because it'll be a little bit faster then. And I think actually this can just be value. Okay, so the only thing that's going to happen in this sweep is it's just going to run, I guess actually, no, let's do 2 batch sizes, so it's a little bit more interesting. Okay, so in this sweep, there's going to be some runs which have a different pixel set encoder sample size, and some runs that are going to have a different batch size. So when I click initialize sweep, what this says now is that on your own machines, launch one or more agents to run the sweep. When you launch an agent, this agent will become your sweep. This agent will become your sweep dashboard. So basically what this means is that weights and biases is not going to run these models for me. Like I still need my own machines somewhere to run these models, but I don't need to run these training scripts myself. I just run these agents, and then the agents, inside of these agents, those scripts are run for me. So I'll show you what that looks like. I'm going to copy and paste this line, and I'm going to go into my bash terminal over here. And I already have, I guess I already have a machine running right now with the GPU. So I'm going to just go ahead and paste this script, wandb agent, whatnot, and run it right from here. So what this is going to do is it's going to start the agent. And the agent figures out what command it wants to run. So you can see over here, it runs this particular Python train.py, and it uses a particular batch size, and it uses a particular sample size. And then it just starts running the command. So there you go. Boom. But that's just one run. If I wanted to have, you know, I can now go into, let's say, another screen like train 2, and I'll just end this model that was running in here. And I can run the agent in here as well. And so now I'm going to have two machines where the agent is running, and therefore where this sweep can kind of exist. Yeah, so I'll just let that load. And this is really where this is where the sbatch command comes in that I started talking about earlier. So where if I go back over here, instead of just doing a screen for each one, I can actually just tell each of these compute nodes, like, just run that agent, and that's it. Like I don't need to worry about what's happening there, just run it. And so I have a particular command for this, or like a little script. I can actually open it up quickly. It just tells the slurm which how to set up the machine. So it tells it to use the GPU, to like give it 48 hours, and some other commands, and it tells it to make sure to activate the Python environment. And I can just run this. So sbatch, so send a command to a machine, then sb.sh, that sets up all the parameters for that machine, and then on that machine run the agent. And so I'm going to just run that, and I can run that like a bunch of times because I have access to a lot of GPU. So, and I can see how many I have running. Right now I have this many machines that have this particular command running on them. And you can see that actually, like, the nodes for some of these are the same. This is because that cluster doesn't necessarily, just because a compute node has something running on it, doesn't mean that there can't be something else running on it, because there might be space. So it might send actually multiple runs to the same compute node. Okay, so I have all those things running, so I can go back over here to weights and biases, and I can click view sweep, and I can click on runs, and I can see I have 4 already. Cool. And I'll probably have more soon over here. And these are basically all of these runs that are starting to run. Actually, I'm only going to have 4 because I only had 4 different parameters, I think, that I made possible. But basically, I have 4 different runs running over here, and it makes it very easy to compare. Training is going to take some time, so I'll just show you a previous sweep that I had. Let's see. Maybe, yeah, to just show you the kind of the power of weights and biases. So here's a sweep where I have a lot of stuff going on, 37 runs, and I was particularly interested in how these, like, temporal dropout, in this case, how temporal dropout and this pixel set encoder sample size affected the max accuracy of the model. So you can set up these cool diagrams, which basically compare all of these parameters across multiple runs. And what I can do over here is, well, I can look at individual runs. So here's one run which has, like Sentinel-2 dropout set to 0.4, and then Sentinel-1 dropout set to 0, and then the pixel set encoder sample size at 8. And I can see what its accuracy is. But I can also just drag over here and select a couple and just look at if there's some trends that I see. Maybe I'll make this a little bigger. So yeah. So here I've selected the models which have the highest max accuracy, and I can generally see that like what lights up is generally stuff that's near the bottom, or which has a lower pixel set encoder sample size. So like a lot of these good runs are going through a pixel set encoder sample size of 8 and 4. But if I move this line to see some of the worser runs, then the ones that light up are the ones that have a high pixel set encoder sample size. So this kind of helps me generally see some trends about, you know, what's happening within a lot of these, across a lot of these runs. So that's super neat. And then I have all these, you know, I can look at a million confusion matrices together if I want, or a whole bunch of metrics together. So that is pretty cool. And then I just as well, if I mess up a sweep or something, or like, I guess this one finished because there wasn't that many parameters, but I can easily just delete it and delete all the runs so that they don't clutter up my workspace, and then they are gone forever. And all those machines that I had running them, I can just run this. They're not running anymore because they're not being used. So that's more or less weights and biases. And just kind of as a concluding thing, all of this code is in this particular repository. There's the train.py file that I showed, and there's some example weights and biases sweeps in here. So I can share this on Slack, or if you're interested, you can just message me, but it's on my, I think it's public on my repo. So that's pretty much it. I guess I've been talking for a while. Oh, and there's some chat messages that I didn't see, but yeah, any questions, I'm be happy to answer them now.
This is really awesome.
Thank you.
I want to use this.
Okay. Should I read through these chats, or should
Here, I can go through this. Some of them have been answered. So let's see. Okay, Gabby, you did have a, starting from the beginning, your question about SGD versus Atom.
Oh yeah, SGD versus Atom. I used Atom. The reason that I was that I tried SGD was because I wanted to try a different like a cool learning rate scheduler, like one of those that just like does super convergence and like trains super fast, but it didn't work in the end, so I just used Atom.
And then yeah, I was wondering about slurm. Like this is not like this is only capable of like accessing GPUs or nodes that are already on the machine that you're logged into, right? You wouldn't use this for like, it'll automatically go like spin up infinitely many instances if you were on GCP or something.
Yeah, I don't think, yeah, it wouldn't. Like this particular one is set up by and managed by the Center of Machine Learning, and they have like limit, like there's only, even though I can run a decent amount of GPUs, like there's still a limit to how many I'm allowed to, and I have to use this particular scavenger account because that's the account that kind of takes whatever's left over. It doesn't have any priority.
Right.
But I could see how on GCP, essentially, like just a basic version would be spinning up a couple of VMs and then just running the agent command on those VMs. That would be pretty close.
Yeah, and then we had a later question. I think Gabby and I were both asking, like, does this, can you parallelize that automatically by running the same agent? And the answer turned out to be yes.
Yep.
Which is super cool.
Yeah, especially when you just like run it like 10 times and boom.
Yeah.
That was nice.
Yeah, so okay, the keys that you were showing that you were putting in the dict, are those like a complete set, or is there like a whole bunch of things that you could log? You just were doing a few.
I was logging everything possible. And actually, this is just like a general lesson that I got from doing this project and from doing using weights and biases to like a large degree, is that like the more you log, the better. Because it's just like a lot of this logging is kilobytes. So it's really not that much information. Actually, just on that note, I just recalled a couple of some other things that I did not share, but you can also easily log images, you know, and when like for a lot of this, for a lot of this, for a lot of these projects, you want to actually see images of the satellite data. And somewhere in here, okay, no, never mind. But I used to have a project in here which had the those like forecasts being logged, and so you can just send entire images up there. And unlike honestly, this is the primary reason that I switched, was because I was logging these images to TensorBoard before, and it would just like freak out after a couple megabytes because it would have to like index through them every single time. Whereas weights and biases can like fairly easily handle large amounts of image data, and you can look at a whole bunch of images. Like for each epoch, you can log an image and be fine.
And are you running like a wandb server here? Or no, this is just connecting to the website. Like whereas TensorBoard, you run a server.
Yeah, this is just a website. So it's free for academics and students. I think once you start having a business, then you have to pay, but yeah, they just host this for free.
Awesome. Gabby was asking, is the Winter Dragon name automatic, or can you modify that?
Yeah, it's automatic. And I did modify it. Actually, something else that I did not mention, but that proved really useful in the competition, is using tags and specific names. So basically, every time I made a submission with the model, I would tag it with a submission tag, and I would change the name to be the score that I got and the epoch that the score was recorded in. And that way I could easily look at, like you can see right now, my screen has all these scores for each different model. But the model still retains, like this particular run still retains a particular ID somewhere. Let's see.
Like, no.
Oh, I guess it's in the URL for sure. So I use this ID that's in the URL. This is what actually I used to name all the models that I saved, and what I used when I made competition submissions, so that I would just paste this link in the description of the submission, so then I could go back and forth easily.
Oh, it's also in the run path. Yeah.
Yeah.
Cursor is.
Okay, I have a last, it's maybe a higher level question. I don't know if you have an answer to this, but how much did you actually tweak the hyperparameters? That it's like giving me anxiety looking at all your runs, and like just like trying to figure out what the hyperparameters should be from that.
Yeah, that's a good general question. I mean, ultimately, like the biggest gains came from the biggest gains for this competition came from going from using Sentinel-2 and Sentinel-1 data, which had a smaller temporal dimension, to using Planet Daily data, which had like the temporal dimension was 244 compared to 100 something or less for the Sentinel-2 ones. So the biggest boost was from the change in data. But when I was doing like experiments with the pixel set encoder, which is like the state of the art architecture for this crop classification kind of domain, that one, like the default parameters were not did not work great. Like the default parameters were actually like the example I showed where it was like pixel set encoder sample size 32 compared to 4. Like that was an actual finding that was beneficial from that, and like which actually affected results significantly, but not as significantly as changing the data. So yeah, overall, the biggest boosts were still provided by like these kind of data-centric changes, but I think in terms of challenges where you do want to find like the best solution that you can with the data that you have, it makes sense to do some of this. And it's also just,
Andrew Ng would be proud. Go on. Oh, sorry, I interrupted you.
sorry, I just said it's just nice to look at too. It's a nice UI.
And then the last questions were just about storing the logs. So like, I'm guessing the logs are stored somewhere that you specified, like on that machine that you're running it on. Or is it where are the logs stored? And then Gabby's question related to that was, does it store models?
Yeah, the logs, I mean, the logs are always going to be stored, I think, in the like inside of weights and biases, but I mean, in this case, they're not that useful because TQDM fails, I guess, in this case. But the logs for each like slurm run, I would store as text files, and then I would store text files to just basically check if, in case there was something that was breaking, and then I would just periodically delete them. So I have a couple over here, for example. But yeah, I guess, yeah, actually these are the ones that just happened. I think they just, in this particular case, I started the agent in these machines, but there wasn't actually any runs available because there's only 4 hyperparameters to tune. So it just ended. I'll just delete these periodically.
Sorry, I meant the data that's logged, like all the losses and everything, like the whatever it's reading to visualize that.
Yeah, so those are actually stored. There is like a wandb folder here, that local, that's stored, but it's basically made to sync up to the weights and biases server. So you can run like weights and biases clean, and it's going to basically delete all of this if it's available online. But it's stored locally as well as online.
Okay. But it's not storing the model files, or it is?
Well, the model files, the storage is up to you, basically. So I did have, and this is the train. Oh no, this is the wrong file. Here's my train.py file. So I had a line up over here. Let's see. If it's the model threshold is bigger, the save or the validation loss is smaller than the model save model threshold, then make a directory and save the model, just torch.save locally. And I ended up using this more, even though I had a line over here where I could save models to weights and biases, like to store them on there. The issue is that weights and biases, like, I guess for models, I was saving it with the optimizer before, and like that started to take up space. There's only 100 gigs available, which is a lot, but if like some of these models, they'd be like more than a couple gigs. So then a couple models or a couple runs, that's going to start pushing you to the limit. And I also found that like after I did a couple of training runs, then I would I'd want to run like the submission, like run through the test, make all the predictions for the test data. And to run that, I have to have the model locally or like on this machine anyway. So there was not really a point in me pushing to weights and biases and then pulling the model back from there. I still saved it just in case, like just a model, one model from the run, but I never actually ended up using this.
Okay. Cool.
Cool. Okay. Thank you.
Thanks. Everybody ready to go use weights and biases now? And final question, is it wandb or wandb?
No idea. I might, yeah, somebody actually like messaged me recently from there to have a call, so maybe I'll ask.
Mm.
You have to, it's like wandb.
Yeah, then I'm just gonna end the call, I think, at that point. But, actually, also on that note, I have that NASA Harvest entity, and I think it would be neat if we just put like all the projects that we had related to NASA Harvest, if we put it in there. So feel free to just, if you're thinking of using weights and biases, feel free to just contact me and I'll add you to that team so that we can have all our runs in one place.
Cool. All right. Thanks, Ivan. I'm gonna
That
stop.
was awesome. Thanks, Ivan.